Hello everyone, welcome to Module 2, Optical Satellite Images, Basic Concepts and Operations on Landsat and Sentinel-2 MSI. This tutorial will walk you through how to find and visualize image collection of satellite data available through Google Earth Engine. We will also describe different methods to mask clouds, filters, and finally export results. In this exercise, we will use Landsat data, but most examples can also be applied to any other satellite data available through the Earth Engine. Learn more about the list of satellite data in Earth Engine Data Catalog.
So first, what is image collection? Most datasets in Earth Engine come as an image collection. An image collection is a dataset that consists of images taken at different time and locations, usually from the same satellite or data provider. It is identified as EE.image collection into the script. Each data source available on GEE has its own ID, like the SRTM image you have been working with in previous modules. Image collections also have an ID. As with single images, you can discover the ID of an image collection by searching the Earth Engine data from Catalog, from the code editor, and looking at the details page of the dataset. For example, search for Landsat 8 TOA and click on the first result, which should correspond to the USGS Landsat 8 Collection 2 Tier 1 TOA reflectance dataset. You can do two steps here. Either import that dataset using Import button and rename it to Landsat 8. Or another step for the beginners is to go back to your dataset, copy the collection snippet ID, this one, into the image collection constructor, like this. Introduce a new variable with any name you want to assign your dataset. I will go with Landsat 8. Next, to import your image collection, you have to use a function called as EE.ImageCollectionConstructor. In this constructor, you have to paste your collection snippet ID, like this. If you want to see the description of image collection in your console, you have to print it. Print your variable. Remember, in Earth Engine, you cannot print any dataset without calling it as a variable. Run your script. This error happens because the print function is limited to returning a maximum of 5,000 elements at a time. If your image collection contains more than 5,000 images, you cannot print them. Collections larger than 5,000 images will need to be filtered before printing. So, what is filtering an image collection? The collection contains all global imagery ever collected by the sensor. The entire collections are not very useful. Most applications require to extract a single image or subset of images. We use filters to limit the collection by time or location and to set the appropriate images. There are many types of filter functions. Go into Docs tab and look at EE.filter to see all available filters. We will learn about two main types of filtering techniques. First is filter by location. This command is used to filter the collection of images that cover a particular location. If you want to work on a particular location rather than the whole world, first pan to your area of interest and define your area of interest with a point or line or polygon using the geometry drawing tools here. I will choose surrounding areas of Manchar Lake of Pakistan for better visualization of our results. Get the polygon drawing tool and make a polygon in your area of interest, like this. Name the import polygon variable. I will go with location. You can keep using the default name geometry if you like. Now, to filter your collection within defined area, Earth Engine provides filter bounds function. To filter image collection by geometries, just type dot filter bracket and then dot filter dot bounds, which is a function. Inside brackets, add your geometry variable, which is named as location. This will filter your area according to the polygon you have created. Alternatively, you can use a single geometry collected by adding a marker on your particular location, like this, and filter bounds by this geometry, or defining latitude and longitude, like this. Add a marker. It will import lat and long of your location in the geometries. Now, create a new variable with name point. Add function dot geometry point from doc tab here, and then in brackets add your coordinates like this. So we have filtered our collection by location. Now we will filter it by date. Earth Engine provides a filter date function to filter the collection by defining a date range. In this exercise, we will filter our Landsat 8 image collection for the year 2022 only. The filter date function requires two parameters. Start date and end date means the date of starting filter and the date of the ending filter. We will choose the month of June as the starting date, and as ending date we will choose August. These are the 2 months of monsoon season. We can define the start date as 2022 6/1 and the end date as 2022 8/31. The date is formatted in year, month, day. Now, filter your collection for the year 2022 by defining a new variable named as date, and then your collection name, and apply filter with start and end, take in single quote, like this. So now, we have applied the filters on our collection. It is time to display them on the map. When a multi-band image is added to a map, Earth Engine chooses the first 3 bands of the image and displays them as red, green, and blue by default, stretching them according to the data type. If you want to change the color, you'll have to change the bands in your visual parameters. In our SRTM image, we just added colors and elevation values because that was a single band image. Now, we are working with a collection of images, so we have to change our bands to control the display, like this. Introduce a new variable named as quiz_params, and then in curly bracket, add band, colon, and then in square bracket, add bands of your choice. From Landsat 8, I will type B4, B3, and B2. If you have no idea about Landsat bands and what color they represent, you can learn about them on its official website. You also need to provide minimum and maximum values suitable for displaying reflectance from a typical Earth surface target. Although lists can be used to specify different values for each band, here it is sufficient to specify 0.3 as maximum and use the default value 0 for the minimum parameter. Now, combine your collection variable and use parameters variable in map.addLayer with a name and hit run to check your result. That's all for today. Thanks for watching.